Everybody, I wanted to go over the answer to the short answer questions from the exam 3. Exam 3 had to do with thermodynamics and equilibrium, or not equilibrium, electrochemistry. And this particular problem had to do with coffee cup calorimetry. So, in part A, the question asks us to calculate the heat transferred when you have this. Process. So the formula is Q equals mc delta T, and that is the formula for heat transfer. And now mass is the mass of the system. Now, this is the one tricky thing here. So we have 50 grams and 10.48 grams. So the overall mass is 60.48. Now, the change in temperature is 41.4 minus 23.6, and so the change in temperature is 17.8. The final temperature minus the initial temperature. And then the C, the specific heat, 4.814, and so that's going to give us, let's see, 60.48 times the delta T. I don't know why I did that one, put that one before the C, but it doesn't matter. It's multiplication. So then we're going to multiply by this specific heat. Okay, and that specific heat is, make sure I plugged everything in correctly. Oh, that's what it is. And so 148. Okay. And so that answer is 4504 joules. Now we want to take this in part B and figure out how many kilojoules are being transferred per 1 mole of sodium hydroxide. So here's how I would do this. Okay, and this is a conversion problem. This really isn't, there's really not a formula here. So this is joules that's released for every gram of NaOH, but it's not every gram of NaOH, it's for every 10.48 grams of NaOH. Okay, so now we want to go grams of NaOH. We want to find the molar mass. So we're going to, because we want to go from grams to moles. So we're going to break out the X line. And so now we go 4504 divided by, before we do that, we actually have to find the molar mass. Na is 23, O is 16, H is 1. 1 plus 16 is 17 plus 23, so this is 40 grams per mole. So it's 40 grams for every 1 mole. So now we can do the math, and we get 4504 times 40 divided by 10.48. And when we do that, we get an answer of 17.190, but that's in joules per mole. So the last thing that we want to do is put that in kilojoules. So we move the decimal point over 3 places, so you get 17.2 kilojoules per mole. Okay, so that's the last of the short answer questions in this section. So I hope that calorimetry problem you were able to do. Okay, have a great day.